Good morning. I welcome you all for one more session of chemistry. So, dear student, in the during last class we have discussed about the optical activity as well as the what uh, structure of glucose. So now the next part of this chapter is cyclic structure of glucose. Right here we have the cyclic structure study also in your syllabus. So, in cyclic structure, how the variation takes place in the glucose molecule, one we will see in detail with the cyclic structure of glucose. So now in this class we are going to discuss about the cyclic structure of glucose is different from cyclic structure of glucose, right? So in your revised syllabus, I don't know clearly there is a Haber structure is there or not. So if it is not there, then no need to go for in detail. So we will check. You just for online, you just remember these points. That's all, and go through your books. So later, if they are there, then definitely anyhow we are explaining once more. So during that those sessions, we will definitely complete these things, right? So now, so here to study the cyclic structure, one we must and should know what are the different form of glucose are present in the nature. So if we see the different, points in the cyclic structure, the first point is regarding the aldehyde group only. So glucose does not react with the Skips reagent, right? Glucose does not reacts with, the spelling is like skips, C yes, sorry, yes, skips reagent, and that reagent sodium hydrogen sulfate, right? The skips reagent, the sodium hydrogen sulfate is nothing but what? Skips reagent. So why the cyclic structure of glucose is not reacting with the sodium, I mean Skips reagent, that is sodium hydrogen sulfate is nothing but in the open structure of glucose, I mean the normal structure of glucose, our aldehyde group was free, right? I have already explained about this. That means because they are free, that's why oxidation was taking place with the bromine water, right? If you remember, so that's why it becomes COOH. Like, but in the cyclic structure of glucose, the aldehyde group is not free, as we see in the normal structure of glucose. In the normal structure of glucose, this is the case. If you remember those last classes, so this is the case with the glucose, but in the cyclic structure, one we cannot see the aldehyde as open or free. So I will show you why it is not free. You just remember in a cyclic structure of glucose, aldehyde not free. So that's why it is not reacting with the Skips reagent. It is a why? Why? Because Skip reagent is a reducing agent. So that means it must and should go. If it is a free, that means aldehyde. If it is a free in a molecule or in a compound, any compound, given compound, then definitely it must and should undergo for the reduction. But it is not doing so in case of cyclic structure. Why? Because in our cyclic structure, aldehyde is not free. This is the first point, right? You need to remember this. In cyclic structure of glucose, cyclic structure of glucose will not react with the Skips reagent. Why? Because in cyclic structure, our glucose in our glucose, whatever the aldehyde is present, which is not free, right? So this is first point. Later, coming to the next point, right? In glucose, in cyclic structure of glucose, aldehyde group interacts with fifth carbon of OH, or see, in cyclic structure of glucose, aldehyde reacts with fifth carbon OH group. So whatever the OH group present on the fifth carbon, it will react it with and it forms cyclic hemiacetal. So what is that? I will explain later. But we will conclude this one right first, and then later we will go for that. So in cyclic structure of glucose, aldehyde reacts with fifth carbon OH. So what is that? See here, if I write the open structure, then it will be like this: third, fourth, fifth carbon. So, and there is a CH2OH. OH, OH, H, OH. So now, alternately H, H, OH, H. So see, to form a cyclic structure, or else in the cyclic structure, the aldehyde group directly reacts with what? Right? Aldehyde group directly reacts with fifth carbon. So if I start giving a number, then this carbon will get what? First priority. Why? Because there is a functional group. First, second, third, and fourth and fifth. So now the meaning of this sentence is, that is, this carbon, I mean the aldehyde carbon will react with the OH group of what? C, to OH group of fifth carbon. That means if I fold it, sir, you can ask why, sir, it is not reacting with the second OH, second carbon OH group, or third carbon OH group, or fourth carbon OH group. Why it is directly going for this fifth carbon only? That is the point. Remember. And one you can ask why, sir, this is very near, no, so it can react with this OH group. So first of all, the reason is why it is getting reacting with the fifth only means here because of crowdness, right? This cannot react with this to form a ring. Two carbon atom will not never form a ring, one point, or cyclic structure. First point. And one more thing, if we fold for third, then definitely there will be a ring or there will be a cyclic structure, but it will be very, very crowded. So what we said in VSCPR theory, in space, the atoms or a molecule, they arranged around the central atom in such a way that there will be a no repulsion, there will be a no attraction, right? So that is the reason why this aldehyde is directly reacting with this to form a hemiacetal group. So what is hemiacetal? I will show you later that compound, right? You remember hemiacetal. It will form after reacting the first, I mean aldehyde carbon atom with the fifth carbon atom OH group, it forms hemiacetal group, right? So next, coming to the third point, this is the second point. Coming to the third point, so the third point is like this. Glucose, I mean, after forming a bond with the fifth carbon atom, glucose, right? After forming with the fifth carbon atom, glucose can produce two forms, right? Those are alpha form and beta form, right? So after formation of a bond with, I mean aldehyde with the fifth carbon atom of OH group of glucose, then hemiacetal group will form, but there may be of two types. That means the glucose after forming a hemiacetal, there is a two chances. One is we can get a alpha form, or else one we can get a what? Beta form of glucose. This is about the third point. Glucose can exist in two crystalline forms. Glucose can exist in glucose. Third point is glucose can exist in two different crystalline forms. Those are alpha and beta, right? Those are alpha and beta as I showed. What is alpha and beta? Again, we will explain with the help of diagram, right? Let me conclude one more point, right? When this alpha form will form, when this beta form will form, and then later we will go for the complete conclusion, right? So now what we came to know after aldehyde, when it reacts with the fifth carbon atom of a glucose, OH group of a glucose, then definitely there will be a formation of hemiacetal. Whenever it will react with the fifth carbon of glucose, then definitely what we will get, the two form of glucose, those are, right, those are alpha as well as the beta, right? So this is the case. Two point I need to clear, right? Next, so see here, the alpha glucose is obtained by crystallization from concentration, by the crystallization of concentration at say this is the very different case. This alpha form we can get, right? This alpha form we can get when we apply a heat up to 303 Kelvin. If I heat this glucose at 303 Kelvin, then it produces what? Alpha crystals, alpha form of crystals, right? If I heat this alpha glucose, a pure solution of glucose, if we heat it, then at 303 Kelvin, one we can get what? Alpha form. And for beta form, we need to heat that particular glucose at 371 Kelvin, right? So if I heat the pure glucose at 371 Kelvin, then definitely what we will get? Beta form of glucose, right? So these are the 4 points, right? These are the 4 points I have explained about. So now just I will give an idea about hemiacetal, alpha, beta, right? We came to know after reacting with the fifth carbon atom, definitely it will form what? Right? What it will form? It will form two different crystals, that is alpha as well as the beta. So see, if I write a original compound of a glucose, then it will be look like this, right? So now see, there are 6 carbons, 4, 5th and 6th, CH2OH, OH, OH, H, OH, right? So now our compound, I mean aldehyde present in this glucose. So if I write H here, then completely I will write H, OH, H, and then H. This is our pure glucose. So this is our pure glucose. When we heat up to what, 371 Kelvin, what we are getting? Beta form of glucose. So now see here, which is very important point. So this, I mean, fifth carbon atom is reacting with what? Aldehyde group. So now after reaction, what happens over here is, so now there is a C hemiacetal, right? So now I am explaining about hemiacetal. C 3, 4, 5, CH2OH. Now there is a bond between what? First carbon atom and the fifth carbon atom. Very important. H is as it is. It might be at the right hand side or it might be at the left hand side. So that's why we are getting two forms, right? And now there is a OH. OH, if I consider this as a here, or else, see now. So after having a bond with this will go up, and now one hydrogen will be attracted on this to form a OH, and this O will come in between like this, right? Understood? I repeat. So OH, that means after reacting, I mean if this OH go and react with this aldehyde group, then already there are four bonds. After this bond, it will become fifth. So that's why it will shift over oxygen. So now negative charge will come. Because of that negative charge, one hydrogen will be attracted by this O and becomes OH. And now one O is left, and this is that one left O. So now this is already gone. Now OH, H, OH. So alternately you can say 1 point. And now one more thing, one more hemiacetal. This is called hemiacetal glucose, right? And this is beta and alpha. I will explain later. So now there is again the same. You just change. You know how this oxygen has came in between. 1, 2, 3, 4, 5, 6 CH2OH. So this is the case OH, 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 H, OH. So now you bring OH this side. So clearly you can see if I write with the different OH and H. So this is the very important case over here, right? These are called as anomers, right? These two are called anomers. Why? Because anomers are nothing but they are having same molecular formula, same structure, but different in their arrangement, right? So this class only I will explain in the next video, right? So the same thing I will explain about alpha, beta, as well as anomers, and what are anomers and how we come to know anomer and all. I will explain in the next class. Thank you.